Hello, today I would like to present to you the TJA1103 demo on features for better link availability and maintenance. Since this demo addresses the functional safety features of the device, let's first have a quick look at functional safety in the automotive context. In the automotive context, functional safety is defined by the ISO 26262 specification. In a nutshell, it defines how to quantify risks due to malfunctioning EE systems and how to take measures to minimize the risk of hazard. TJA1103 was developed according to ISO 26262 and achieved ASIL B safety level. What does it mean in practice? We have safety warning and monitoring features built in hardware in our device, which support the system level safety goal and enhance the availability of communication. So in a system, we have our 1103 next to its safety rated PMIC and safety host controller, which manage 1103 because 1103 can detect certain failures like non-correct supply voltage or that the channel quality is dropping, but the safety host controller needs to take the appropriate action as it has the safety knowledge and compute power to do so. That helps to shorten the system response within the fault-tolerant time interval and to better localize an issue that might occur. Further, it enables predictive maintenance as the diagnostic features from 1103 can be regularly tracked, trend analysis can be done, and with that certain pattern can be seen, and with that predictive maintenance is enabled. Now, without further ado, I would like to present to you the TJA1103 live demo for features for better link availability and maintenance.
Thank you, Jacob, for the introduction. So, as already mentioned, on the left side you see the TJA1103 device, and it's connected to the TJA1101 device on the right side, and in the middle there is the noise source, which is coupling a certain amount of noise into the channel to degrade the link quality. And without further ado, let's now switch to the graphical user interface to show the features of the demo in real time. So in the upper half of the GUI, we see the link monitoring features, the signal quality indicator, the mean square error, and on the right side, the control and PHY status. We have two sliders. One is the channel noise, so we can increase the noise which is coupled into the channel to decrease the link quality, and an SQI warning threshold, which will tell us if the SQI drops below this threshold, and then we can act accordingly. If I now start to increase the channel noise with this slider, we then see that the link quality and the SQI will decrease. At the same time, the mean square error will rise, which gives us real-time information about the quality of the link. As soon as the SQI drops below the SQI threshold, which is this red line, we get an SQI warning. If I further increase the channel noise, which is inducted, we see that the SQI goes to 0 and the MSE will rise further until eventually the link will break down. In the lower half of the graphical user interface, we see the startup self-test, which the PHY performs after each reset or power on reset. So we can now trigger a reset, and then we will see that all safety monitors are fine. And what we now can do is to disable the clock signal and now trigger a reset again, and then we will see that the PHY notifies that some safety monitor features are not okay, and will then eventually tell the safety controller that not everything is fine. So this concludes our TJA1103 live demo for now. If you have further questions or want more information, please reach out to our local sales offices or visit us at nxp.com/ethernet.